All right, we're covering Chapter 2, Section 2. Conjecture is an unproven statement based on observation, so it's a statement. Okay, conjecture is a statement. Inductive reasoning has to do with your patterns. Okay, inductive reasoning is patterns. Looking at example 1, it says, describe how to sketch the fourth figure in the pattern, then sketch the fourth figure. So looking at this, I'm going to look at figure 1 and I'm going to identify that it has 2 sections. Figure 2 has 4 sections. And figure 3 has 6 sections. So looking at it, I have to figure out what figure 4 would be. So looking at it, you can see it's going up by 2, so I know that this is going to have 8 sections. So let me go ahead and draw my circle. I'm separating it, and then I'm shading in one piece. So now for me to figure out what the pattern was. Looking at the pattern, we could figure out that if we're looking at the figure number, the figure number is being multiplied by 2. That's my pattern. All right, looking at example number 2, it says describe the pattern in the numbers 5.01, 5.03, 5.05, 5.07. Write the next 3 numbers in the pattern. So this one's pretty easy. You can see that it's going up, so I'm adding 0.02 each time. And for me to figure out the next 3, all you have to do is add 5.07 plus 0.02. It's going to give me 5.09. If I add 2 more, 5.11 and 5.13. All right, the next question says, numbers such as 3, 4, and 5 are called consecutive integers, so they're coming right after the other. Make and test a conjecture about the sum of 3 consecutive numbers. So easiest way to do this is whenever you're trying to test something, always use small numbers. So test with small numbers, so it's easier. So it says 3 consecutive numbers. So again, I'm just going to start with small numbers. So 1, 2, 3, and the sum means I'm adding. So if I add these together, I'm going to get 6. Again, adding small numbers, 2 plus 3 plus 4, I'm going to get 5, plus 4 would give me 9, 3 plus 4 plus 5, I'm going to get 7 plus 9 is going to give me 12, and then do we see some sort of pattern? So 6, 9, 12, I'm going to try one more, I'm going to go 4, 5, and 6. It's going to give me 15. So I can see that my numbers are increasing. My 6, 9, and 12 are increasing by 3. And then I'm able to identify that the number in the middle is being multiplied by 3. So 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. So with that, we can state our conjecture. Our conjecture would be the sum of any 3 consecutive integers is 3 times the second number. So just going ahead and checking 100 plus 101 plus 102, that's going to give me 303. I'm going to take this middle number and multiply it by 3, and that's going to give me 303. So it's correct. Counterexample. To show that a conjecture is false, prove just one example for which the conjecture is false. So all you have to do is prove it using one example. It could be anything. You're just trying to prove your conjecture false. So looking at it, it says find a counterexample. If you live in Florida, then you live in Miami. We should know one example to make this false. We could say we live in Davie. Davie makes this. Davie is my counterexample. Okay, I'm just proving that this statement is false. All right, example number 4, it says find a counterexample. A student makes the following conjecture about the sum of two numbers. Find a counterexample to disprove the student's conjecture. So I'm trying to make the student's statement false. I'm trying to figure out one example that would make the student's statement false. It says the sum of two numbers is always more than the greater number. So think about it. The sum of two numbers is always more than the greater number. So let's think about two numbers. Easiest one to think about is use negative numbers. So if I were to take -2 plus -3, that would give me -5. Is -5 greater than -2? This is no. So this is my counterexample. I just proved that this statement is false. So far we covered inductive reasoning, which is finding a pattern. Now we're going to cover deductive reasoning, which has to do with facts. Okay, so I'm going to go ahead and write deductive reasoning is facts. Okay, so it uses facts, definitions, accepted properties, and laws of logic to form a logical agreement. These facts are normally things that we already know. So it's kind of like common facts, things we know are true. So things that we know are true, facts that we already know, and then we're going to cover two laws of logic. So the first law is going to be law of detachment. One way to think about this is the word detachment. You're separating your two conditional statements. So the law of detachment, if the hypothesis of a true conditional statement is true, then the conclusion is always true. So keep in mind that this has to do with a true conditional statement. So it says, if it's Friday, then I eat pizza. That's my true conditional statement. So let's just pretend every Friday we eat pizza. So I'm separating it. If it's Friday, then I eat pizza. If today's Friday, I will eat pizza. So it's telling me that it's something true. So it's giving me a full conditional statement. If it's Friday, then I eat pizza, which is my hypothesis and my conclusion. Then I'm separating it. Okay, I'm separating it to today is Friday. I will eat pizza today. Law of syllogism. It says used when the conclusion of one of the statements is the hypothesis of the other statement. So looking at it, you have a statement that's overlapping. You have your hypothesis first, then your conclusion. Then your conclusion will become your hypothesis, then you're going to become another conclusion. So it means if these are both true statements, my hypothesis and my conclusion should always be true. It should work. So I'm able to make it a true statement. So let's go ahead and look at an example. So given two true conditions, write a new conditional statement. So it says, if it's Friday, then I will go to the movies. If I go to the movies, then I eat popcorn. So one thing to think about when in law of syllogism, you are blending the two together. You're blending the statements together. It's a blend. Together. So before detachment, I was separating them, but now I'm blending them. So you're gonna take out the overlap. So looking at this, what's overlapping? Then I go to the movies, and if I go to the movies, that's gonna give me my final statement. So my conclusion would be, if it's Friday, then I eat popcorn. All right, so let's look at example number 5. It says, if 90 degrees is less than the measure of angle R, which is less than 180 degrees, then angle R is obtuse. The measure of angle R is 155 degrees. Use the law of detachment. What statement can you make? So looking at this one, I have my statement. I have my conditional statement. So I'm going to go ahead and highlight my hypothesis. 90 degrees is less than the measure of angle R, which is less than the measure, which is less than 180. And then my conclusion, angle R is obtuse. So again, detachment means I'm separating it. So I'm going to pull these two apart. So now they're telling me the measure of angle R is 155 degrees. This is giving me my information for my hypothesis. So what statement can I make now? The statement that I could make is the angle R is obtuse. Okay, so I broke them apart, I pulled them apart, and I made two statements. So looking at example number 6, it says, if Janelle gets a job, then she could afford a car. If Janelle can afford a car, then she will drive to school. Using the law of syllogism, what statement can you make? So with this one, I have two conditional statements. I'm going to highlight what I have. If Janelle gets a job, then she can afford a car. And if Janelle can afford a car, then she can drive to school. So I'm getting rid of my overlapping. I'm blending them together. So I'm going to go ahead and take out she can afford a car because that's repeated, and I'm getting rid of my overlap, so I'm going to blend them together. So my statement would now be, if Janelle, should be an E, gets a job, then she will drive to school. And that's what my statement would be. This says, state the law of logic that is illustrated. If you get an A on your math test, then you can go to the movies. If you go to the movies, then you can watch your favorite actor. If you get an A on your math test, then you can watch your favorite actor. So I need to figure out which law this is. So again, just highlighting what I have. If you get an A on your math test, then you can go to the movies. If you go to the movies, then you can watch your favorite actor. So this is getting rid of my overlap in my statement. So this is now just saying, if you get an A on your math test, then you can watch your favorite actor. I'm getting rid of you can go to the movies. So this is telling me that this is the law of syllogism. Syllogism. Alright, example number 8 says state the law of logic that is illustrated. It says if x is greater than 12, then x plus 9 is greater than 20. The value of x is 14, therefore x plus 9 is greater than 20. So this is giving me my hypothesis. Oops, highlighted a little too much. This is my hypothesis, and they're also giving me my conclusion. So then this is saying that if x is 4, so they're telling me what my x is. Therefore, that x plus 9 is greater than 20 would be true. So this would be law of detachment. In the last example, it says determine whether inductive or deductive reasoning is used to reach the conclusion. Explain your reasoning. So look at the first one. It says each time Monica kicks a ball up in the air, I can't really see, it returns to the ground. So the next time Monica kicks a ball up in the air, it will return to the ground. All reptiles are cold-blooded. Parrots are not cold-blooded. Sue's parrot is not a reptile. So let's go back to inductive and deductive reasoning. Inductive reasoning is based on a pattern, while deductive reasoning is based on facts. So looking at the first one, it's giving me a pattern. It's kicking the ball up in the air, it's coming down, it's kicking the ball up in the air. So they're specifically giving me some sort of pattern. So this is a pattern. Oops, I put way too many E's in there. So I explained it by saying it's a pattern, therefore it's inductive. Looking at the next one, it says a reptile are cold-blooded. This has to do with facts. Okay, facts. Therefore, it is deductive. Alright, please make sure you guys are studying these vocabulary words: inductive, deductive, law of syllogism, law of detachment, counterexample, because you will see questions like this on your quiz and on your test.